In part 3 of the Unit 1 notes, we will be covering calculating volume of a regular object, calculating volume of an irregular object, and calculating density. The volume of a regular object can be found by multiplying the length times width times height. Here we are trying to find the volume of a glass vase below if it has a length of 12.5 centimeters. This vase appears to be a cube, which means the length, width, and height will all be the same exact measurement. So in order to calculate the volume here, we would simply take our 12.5 centimeters and we're going to cube it or multiply it by itself 3 times. After we do this, we're going to end up with 1,953.125 centimeters cubed. The units here are multiplying through as well. So we now have a new unit for our volume. Now we do need to round this based on something called significant figures, which we have not covered yet. I'm going to round it based on the significant figures right now, which would be 1,950 centimeters cubed. But as of right now, if you left it as your long answer, that would be perfectly acceptable until we learn how to cover the significant figures. Next, we are trying to find the volume of a fish tank with a length of 51 centimeters, a width of 27 centimeters, and a height of 32 centimeters. So because this is no longer a cube, we have the 3 different measurements that we're going to be multiplying. So I have 51 centimeters. I'm going to multiply by 27 centimeters and then by 32 centimeters. When we multiply across, we end up with 44,064 centimeters cubed. And again, I'm going to round this based on significant figures, so it would round to 44,000. But we don't have to be concerned with how we end up with that rounding yet. Now for something slightly more complicated, the volume of an irregular object. Due to the irregular shape of some objects, it is not possible to perform a length times width times height calculation. However, we can submerge the object in water and measure the displacement. This is known as Archimedes' principle, and there is a TED-Ed video which you will be watching which is based on this. The volume of water within a graduated cylinder is 150 milliliters before a stone is added, and 180 milliliters after a stone is added. What is the volume of the stone? Well, the change in the water level is based on the object which is now submerged within the water. So if we subtract these two values, we should be able to find the volume of the object that was placed in the water. So all we have to do here is take 180.0 milliliters. We're going to subtract 150.0 milliliters since that is the volume of the water, and we end up with 30.0 milliliters. Now our question on the bottom here, do the units make sense for a solid? The answer would be no. We typically use the unit of milliliters when we're talking about the volume of an object. You may or may not know this, but the unit of milliliters is actually the same exact thing as centimeters cubed, or cc's, if you've ever heard that in terms of maybe a shot, so something related to the medical fields. So since I'm talking about a solid object here, it would be a little more accurate to say that the volume of the solid is 30.0 centimeters cubed. So that would be a better answer. All right, here we are looking at finding the volume of another irregularly shaped object. We are starting with a value of 50.0 for our water, and it is going up to 75.0. So we are again just going to subtract these two values. And just like before, since this is a solid object, it doesn't really make much sense to keep this unit of milliliters, since that is really just the amount of water displacement that occurred. We would say that the volume of the object is 25.0 centimeters cubed. Our final topic for this video is density. Density is a measure of the amount of matter within a given space. You must be able to manipulate the formula to solve for all three of the variables. This is a very important concept because it will be related to many of the other formulas we will be using throughout the year. So there are little tricks that you can use to try to solve for each of the variables for density, but it is important that you learn how to manipulate the equation now. If I'm starting and I'm trying to find density, the equation's good to go. D is already solved, so I could just plug my numbers directly in. But what if I was trying to find the mass? So what if I wanted this variable by itself? That means I need to do something mathematically to get this volume to the other side of the equation. What I could do is multiply both sides by volume. As long as I do the mathematical operation to both sides, it's allowed. And now since volume is on the top and bottom of this fraction, that's going to cancel out. So I end up with a new version of the equation, mass is equal to volume times density. Now let's say I'm starting with that original equation, but what I actually want is volume, so I'm trying to solve for this variable. This is a little more complicated. There's a couple of ways that you could solve it. I could divide both sides by mass, because top and bottom, the mass will be eliminated. But the problem here is that you didn't actually solve for volume. When these two variables cancel out, a 1 is left in its place. So what you've solved for is 1 over volume. So there are a couple ways you can fix this. You could flip both sides of the equation. So we're going to flip the bottom and top on both sides, so that we end up with mass over density, which is now equal to volume. An alternative is that you can actually solve the equation a different way. So let's again start with D equals M over V. The first thing that we can do is multiply both sides by volume, just like we did in our previous example when we were trying to find mass, just to get it out of the denominator. Now that it's out of the denominator, I can divide both sides by density in order to get volume by itself. So volume is equal to mass over density. And this is the same exact equation that we ended up with over here. So here you can see the three possibilities for the density equation. While it is fairly simple and you might be able to just memorize the three versions of the equation, on your test you might have to actually prove that you know how to move the variables around by showing your work. So make sure that you're comfortable with doing so. Our units for density are going to be grams per centimeter cubed or grams per milliliter. There are other possibilities for units, but those are the ones that we are going to be using in our class. All right, so next up we are going to be doing an example for density with another checkpoint question. And again, I want to remind you that you should be writing out the solutions to each of these checkpoint questions in your notebook. We have a steel cube, which is placed on an electronic balance, and the mass is determined to be 1006.25 grams. Each side has a length of 5.0 centimeters. What is the density? Now, the way I would like you to solve these problems, there's a process, and I want you to go through the same process every time. First, identify what equation you're going to be using. We've only covered one equation so far, so we know we're using density equals mass over volume. Next, I want you to write out each of the letters and identify what they are based on the word equation. So we had our 1006.25 grams. Well, that's going to be a mass because grams is a unit for mass. What is the density? That means that's what I'm looking for. So I usually put a question mark in that spot. And finally, volume. Now, a common mistake in this type of problem is to plug in the 5.00 centimeters right down here. But this is not actually a volume. And I do have the hint here. We have to find volume first. We know it's a cube, so every side is the same length. I simply need to do length times width times height here. So I have my 5.00 centimeters, and I'm going to cube that whole thing. So that means that my volume is actually 125 centimeters cubed. So that's what I'm going to be using here. You won't always have to do that extra calculation. Most of the time, they'll just give you the volume to start, or maybe it's an irregular object type problem where you have to do the subtraction first. Now that I have each of these filled in, I need to decide if I have to manipulate my equation. I'm looking for density, and density is already solved for. So that means I can just plug in my numbers directly. Density is equal to mass over volume, so I'm going to take my number for mass and put that on top. Now I'm going to divide by my volume, which is 125 centimeters cubed. From here, I simply need to divide, and I end up with 8.05 grams per centimeter cubed. That 5 is not very clear, so I'm just going to try to fix it. And that's our final answer. All right, we have one more checkpoint question for density. The density of lead metal is 11.34 grams per centimeter cubed. The mass is found to be 4.39 grams. What is the volume? Well, I can see that this is a density question, so I'm going to use the equation D equals m over v. Just like before, I'm going to list out each of my variables and try to pull those numbers from the word equation. They're telling me that the density is 11.34 grams per centimeter cubed. And the mass is 4.39 grams. What is the volume? So that's my question mark. So this time, I'm trying to get the volume by itself. That means that I need to manipulate this equation in order to get volume by itself. Now, I'm going to walk you through how to do this again. This is exactly what I demonstrated on one of the previous slides. I'm going to start by multiplying both sides by volume, because I just want to get it out of the denominator. So now I have this new version of the equation. Volume times density is equal to mass. Now I want to get volume by itself, so I'm going to divide both sides by density. And again, I have a new version of the equation. Volume is equal to mass over density. Now that I have solved for the variable that I'm looking for, I can plug in my numbers. So my mass is 4.39 grams, and my density is 11.34 grams per centimeter cubed. Here the grams are both going to cancel out, and I'm left with a unit of 1 over centimeters cubed, which is actually the same exact thing as just saying centimeters cubed. That's a unit of volume, so I know I set up my equation correctly. From here, I would just plug my numbers into a calculator, and I can see that I have 0.387 centimeters cubed. Now make sure that you're writing out all of this work. This is exactly what I would expect for any test or a quiz. And for my assessments, the work is typically worth just as much as the actual answer, if not more. So it's very important that you're actually showing everything that I have here. That concludes the Unit 1 notes video for Part 3. When we come back for Part 4, we are going to be covering scientific notation.